Today we are looking at Class 9 Mathematics, Triangles, Exercise 7.1. Let's look at the first question. In quadrilateral ACBD, AC equals AD and AB bisects angle A. Show that triangle ABC is congruent to triangle ABD. What can you say about BC and BD? First, let's look at the given data. We find from the diagram that AC equals AD. Also, they've given that AB bisects angle. So, we can say that angle CAB is equal to angle DAB. In this question, we need to prove that triangle ABC is congruent to triangle ABD. How can we prove that? Let's look at the diagram. Comparing both the triangles ABC and ABD, we find that side AC equals side AD and also angle CAB equals angle DAB, which are both given data. Also, we could say that side AB equals side AB because it's common in both the triangles. So, what congruency is this? By side angle side congruency, we could say that triangle ABC is congruent to triangle ABD. But the question isn't over yet. Let's look at the second part of the question. What can you say about BC and BD? Since we have already proved that triangle ABC is congruent to triangle ABD, now we can easily say by corresponding parts of congruent triangles that side BC is equal to side BD. Hence proved. Now let's look at the next question. ABCD is a quadrilateral in which AD equals BC and angle DAB equals angle CBA. Prove that triangle ABD is congruent to triangle BAC, BD equals AC and angle ABD equals angle BAC. Let's look at the diagram. First, we need to prove that triangle ABD, this triangle, is congruent to triangle BAC, which is this triangle. Let's compare both of these triangles. Do you find anything common between both the triangles? Yes, there is. We could see that side AD equals side BC, which is given already. Also, we could see that angle DAB equals angle CBA. Looking at the diagram, we find that side AB is common in both the triangles. Thus, AB equals AB. Now, what congruency is this? Side, angle, side. Thus, by SAS congruency, we could say that triangle ABD is congruent to triangle BAC. Now, let's look at the second one. BD equals AC and the third one, angle ABD equals angle BAC. Since we have already proved that triangle ABD is congruent to triangle BAC, by corresponding parts of congruent triangles, we could say that side BD is equal to side AC. Also, angle ABD is equal to angle BAC. ABD is equal to angle BAC. Hence proved. Now let's look at question number 3. AD and BC are equal perpendiculars to a line segment AB. Show that CD bisects AB. That is, OA equals OB. First, let's prove the congruency between triangle OBC and triangle OAD. We could say that side AD equals side BC an angle OAD equals angle OBC, which is 90 degree. Since AD and BC are equal perpendiculars to the line segment AB, we could also say that angle DOA is equal to angle COB. Why? Because they are vertically opposite angles. So what congruency is this? By angle side AAS congruency, we could say that triangle ADO is congruent to triangle BCO. Hence, by corresponding parts of congruent triangles, we could say that OA equals OB. Thus, CD bisects AB. Hence proved. Question number 4. L and M are two parallel lines intersected by another pair of parallel lines P and Q. Show that triangle ABC is congruent to triangle CDA. We need to prove that triangle ABC, which is this triangle, is congruent to triangle CDA, which is this triangle. How do we prove that these two triangles are congruent? Let's see. Since line L is parallel to line M, we could say that this angle is equal to this angle. How? By alternate interior angle theorem, we could say that angle DAC equals angle BCA. Similarly, since line P is parallel to Q, by alternate interior angles, we could say that this angle is equal to this angle. Thus, angle BAC is equal to angle DCA. Also from the diagram, we could see that the side AC is common in both the triangles. So AC equals AC. Now what congruency is this? Angle, side. So by AAS congruency rule, we could say that triangle ABC is congruent to triangle CDA. Hence proved. Now let's look at the next question. 5. Line L is the bisector of an angle A and B is any point on L. BP and BQ are perpendiculars from B to the arms of LA. Show that triangle ABB is congruent to triangle AQP and BP equals BQ, or B is equidistant from the arms of angle A. Equidistance means equal distance. Now first let's prove that triangle ABP is congruent to triangle AQB. Looking at the figure from both the triangles, we could say that angle QAB equals angle PAB. Why? Because line L is the bisector of angle A. So it divides angle A into two equal halves. Also, we could say that angle BQA equals angle BPA, which is 90 degree, because BP and BQ are perpendiculars from B to the arms of LA. From the figure, we could also say that AB equals AB, because AB is a common side in both the triangles. Thus, by AAS congruency rule, angle side, we could say that triangle APB is congruent to triangle AQB. Also, by corresponding parts of congruent triangles, we could say that side BP equals side BQ. Hence, B is equidistant from arms of angle A. Hence proved. Question number 6. In figure, AC equals AE, AB equals AD, and angle BAD equals angle EAC. Show that BC equals DE. First, let's prove the congruency between triangle ABC and triangle ADE. So, in triangle ABC and triangle ADE, AC equals AE and AB equals AD given. Also, it is given that angle BAD equals angle EAC. Let's add angle DAC on both sides. Thus, angle BAD plus angle DAC, which will be equal to angle EAC plus angle DAC. Let's look at the diagram. BAD plus angle DAC will become angle BAC. Similarly, angle EAC plus angle DAC will become angle EAD. Hence, from equation 1, 2 and 3, we could say that by SAS congruency, triangle BAC is congruent to triangle DAE. Now, by corresponding parts of congruent triangles, since triangle BAC is congruent to triangle DAE, we could say that side BC is equal to side DE. Hence proved. Let's look at question number 7. AB is the line segment and P is its midpoint. B and D are points on same side of AB such that angle BAD is equal to angle ABE and angle EPA is equal to angle DPB. Show that triangle DAP is congruent to triangle EBP and AD is equal to BE. First, let's prove that triangle DAP is congruent to triangle EBP. How do we do that? We know that angle APE is equal to angle BPD from the question. Let's add angle EPD on both the sides. Thus, it will become angle APE plus angle EPD, which is equal to angle BPD plus angle EPD. Looking at the diagram, we see that angle APE plus angle EPD is equal to angle APD, which is equal to angle BPD plus angle EPD is equal to angle BPE. So, we found that angle APD, which is this angle, is equal to angle BPE, that is this angle. This will be equation number 1. Also, angle BAD is equal to angle ABE from the question, which will be equation number 2, and AP is equal to PB, which is equation number 3. So, from equation 1, 2 and 3, we could say that by angle side angle ASA congruency, triangle DAP is congruent to triangle EBP. Thus, by corresponding parts of congruent triangles, we could also say that side AD is equal to side BD. Hence proved. Question number 8. In right triangle ABC, right angled at C, M is the midpoint of hypotenuse AB. C is joined to M and produced to a point such that DM is equal to CM. Point D is joined to point B. So, side AM is equal to MB and DM is equal to MC. Also, they have given that ABC is a right angled triangle at angle C. First, let's prove that triangle AMC is congruent to triangle BMD. We could see that AM is equal to MB and DM is equal to CM, which is given in the question. From the diagram, we could see that CMA angle is equal to angle BMD because they are vertically opposite angles. Thus, by side angle side SAS congruency, we could say that triangle AMC is congruent to triangle BMD. We have proved that triangle AMC is congruent to triangle BMD. Now, let's look at the next one. We need to prove that triangle DBC is a right angle. We need to prove that angle DBC is a right angle, which is angle DBC is 90 degree. Since we know that triangle AMC is congruent to triangle BMD, we could say that by CPCT, angle ACM is equal to angle BDM and side DB is equal to side AC. Since angle ACM is equal to angle BDM, looking at the figure, angle ACM, this angle is equal to angle BDM, this angle. These two angles form alternate interior angles if you look carefully. You see Z shaped here, Z forming. So we could see that BDM angle and angle ACM are alternate interior angles. Since they are alternate interior angles, we could say that the side BD is parallel to side AC. Now that side BD is parallel to AC and BC acts as a transversal, we could say that angle DBC plus angle ACB is equal to 180 degree. Why? Let's look at the figure. Angle DBC and angle ACB both are lying on the same side of the transversal if you look carefully. So these two are interior angles on the same side of the transversal. So we could say that angle DBC plus angle ACB is 180 degree. We know that angle ACB is already 90 degree because it's given in the question. Keeping angle DBC on the left hand side and moving 90 degree to the right hand side, we see that thus angle DBC is equal to 90 degree. Angle DBC is equal to 90 degree. So angle DBC is a right angle, hence proved. Now let's look at the next subdivision. We need to prove that triangle DBC is congruent to triangle ACB. Looking at the figure, we need to prove DBC. This triangle is congruent to triangle ACB, which is this triangle. Let's see how we can prove that. We see that DB is equal to AC by equation 1. And we know that angle DBC is equal to angle ACB because both are 90 degrees. Looking at the figure, we could say that BC is equal to BC. Why? Both these triangles lie on the same base. So they have BC common side. Thus, by side angle side SAS congruency, we could say that triangle DBC is congruent to triangle ACB. Hence, the third subdivision is also proved. Now, let's look at the fourth subdivision. We need to prove that CM is equal to half AB. Since triangle DBC is congruent to triangle ACB, by corresponding parts of congruent triangle CPCD, we could say that side AB is equal to side CD. Side AB is equal to side CD. Looking at the figure, in CD, we could write CD as CM plus MD. Is that right? So we could write CD as CM plus MD. We already know from the question that DM is equal to CM. So now I'm going to replace MD by CM. Thus we can write AB is equal to 2CM. Taking 2 alone to the left hand side, it becomes half. So half AB is equal to CM. Thus we could say that side CM is equal to half side AB. Hence proved.